The Painter application is implemented using the utility application template. So like you've seen previously, the utility application has a main view, or the front side view, and it has a flip side view, which is typically where you have your application settings. And in the case of the Painter app, that's where we allow you to set the line width, the line color, to specify whether or not you want to use the eraser or to clear the screen as well. And we'll take a look at the flip side view a little bit later. We'll start in the main view, or the front side view, with our custom class called Squiggle, which is a subclass of NSObject. And as you may recall, you can add a custom class to your project by right-clicking the folder where you want the class, selecting New File, and then in the dialog you can select Objective-C class, specify the superclass, which for us was NSObject, and then click Next to go ahead and name it. Since we've already done that, let's just go ahead and take a look at the Squiggle class here. A squiggle is going to represent one line. And as you saw during the demo, you can draw multiple lines at once by using the multi-touch capabilities of the iPhone. So for a squiggle, we're going to have three pieces of data: a points NS mutable array, which will store all the points in the line; a UI color called stroke color, which will represent that line's color; and then a float called line width, which will represent the width of that particular line. And we've declared properties for each of these. In the case of the line width, it's an assign property, meaning we're just simply going to copy a floating point value into the line width variable. And in the case of the points NS mutable array, we've declared it read-only because we want to force the client code that creates and interacts with squiggle objects to use our add point method to place each new point into a squiggle. So let's take a look at the implementation of this class. You can see that we synthesize our properties, and again, because points is read-only, it will only synthesize a get method for that property. Our init method is going to first initialize the superclass. Then, assuming that works, we will create our points NS mutable array, and we will also create a stroke color, which is going to be calling the UI color class's black color static method, and we're going to retain that to make sure that that color object exists for the entire lifetime of the squiggle object. And then when a squiggle gets deallocated, we will release each of these objects as well. Now, our add point method has some new capabilities in it. One of the things that you have to keep in mind about a CG point is that it's not a class, it is a structure. And a structure object cannot be stored in an NS mutable array. So what we have to do is take each of the CG points that we're receiving from the multi-touch events, and in order to place them into the NS mutable array of our squiggle, we have to convert them into what we call an NS value object. So here is the operation that actually does the conversion. The NS value method, value with bytes, objc type, which is Objective-C type, is going to take the bytes of whatever object you give it, in this case the point structure object, and it's going to encode those along with the information about the type of the object, CG point in this case, and that will be turned into an NS value object, and NS value objects, because they're reference types, can be placed into NS mutable arrays. So as you'll see later on, we're going to decode this object to actually get the CG points when we need to draw the lines. Now, once we have our NS value object, we will add that object to the end of the points NS mutable array collection. And then finally, we have the dealloc method. When a squiggle gets deallocated, we will release the stroke color, release the points NS mutable array, call super dealloc to deallocate anything that was inherited from the NSObject class, and then we reach the end of the dealloc method. The main view in our utility application is where the drawing will be performed. So class main view, which was created for us as part of implementing a utility application, inherits from UI view, and it has four pieces of data: an NS mutable dictionary called squiggles that's going to represent each of the lines that are currently being drawn. That is, for whatever number of touches there are on the screen at once, that many lines will be in this particular NS mutable dictionary. Then we have an NS mutable array of all of the finished squiggles, the ones that have already been drawn previously. We have a UI color that represents the current drawing color, and we have a float variable that represents the current width, line width. We also declared a couple of properties that are going to give us access to the UI color and line width, and those are used in the flip side view to set the current drawing color and line width respectively. Now, there are a couple of methods that we're declaring for our main view class. We have the draw squiggle in context method, which is going to take a squiggle as an argument and a CG graphics context as well, and it will draw that line on the particular graphics context. And then we have a reset view method, which is going to delete all of the currently being drawn squiggles as well as the finished squiggles in the NS mutable array. We begin our discussion of the main view implementation file by taking a look at the initWithCoder method. Now, as you may recall, any class that adheres to or implements the NS coding protocol, which the main view does, when it gets loaded from the nib file, it will automatically have its initWithCoder method get called. So main view is actually loaded up from the main view XIB file that you can see here under the resources folder. Now, as with any other initialization method, we first attempt to initialize the superclass, and assuming that works, then at line 17 here we create the squiggles NS mutable dictionary, which again will represent the lines that are currently being drawn. And as you'll learn, each of the different touches that's going to be getting processed will have a key associated with it, which we'll use to store the corresponding squiggles in the dictionary. And then we also create the finished squiggles NS mutable array, where we'll store all of the lines that are completed. At line 21, we set our color variable to a UI color object that's created and then initialized with the red value 0, green value 0, and blue value 0, which represents the color black by default, and the alpha value 1, which means that it's 100% opaque. Finally, we set the initial line width to 5 for all of the lines that get created. And these values for the color and the line width will be used with each new squiggle we create unless we change those values using the flip side view. We now take a look at the reset view and drawRect methods. Now let's first talk about reset view, which is going to get called anytime we tell the app to clear the user interface. So here I'm running the app this time in the iPhone simulator, and as it first comes up we have an empty screen. And by the way, I'm going to show you how to do multiple squiggles at once here. If you hold the Option key down, you'll notice that we get two dots that represent basically two fingers touching the screen. And if I now hold the mouse down and start drawing, you can see that I can actually do multiple lines at once, 2 lines in particular. So we have a couple of lines that we just drew. And when I hit the information icon, we go to the flip side view where you can see the clear screen button. And as I demonstrated in the overview of this app, you can also shake your device to cause it to clear the screen as well. But once you hit clear screen, that's going to call the reset view method, and that in turn is going to result in a view that has no items drawn on it. So the way that we get rid of the lines is to go to the squiggles NS mutable dictionary and remove all of its objects, and we do the same for the finished squiggles NS mutable array. So we delete all of the squiggle objects, and of course when you delete each one from a collection like an NS mutable dictionary or NS mutable array, its release method will get called, and that in turn is going to deallocate the squiggle, which in turn will deallocate the information that was stored in each squiggle. At line 33, when we say self set needs display, that's going to cause the view to redraw itself. And if you have an overloaded or overridden, drawRect method for your view, that drawRect method will get called. And we've seen these CG context ref statements previously that enabled us to work directly with the drawing or graphics context so that we could do drawing ourselves on a view. In this case, we're doing that for our squiggles. Previously, we did it, for example, in the Canon game. So at line 40, we get the current graphics context. At line 43 and